Alright, let's look at the homework 7.5, problem number 2. Alright, so let's find the relative extrema or saddle point. Alright, first we need to find the first partials. So I'm going to actually rewrite this guy as quantity 16 minus quantity x minus 1 squared minus y squared to the 1/2 power, because the square root is equivalent to 1/2. All right, so it's a first partial. So partial with respect to x would be, right, put 1/2 in front and keep the inside expression as it is. So it's a 16 minus quantity x minus 1 squared minus y squared. And subtract 1 from the power, so it's a negative 1/2 power. Then we need to multiply by partial derivative of the inside. So that's going to be negative. All right, I guess I have to have a bracket here again. All right, so it's going to be a negative, right, 2 x minus 1. All right, so we got that. All right, then we can just cancel 2 over there and cancel 2 on top. All right, so this is going to be, so this is equal to a negative, right? So we have x, so I took care of the negative sign here. And then we have x minus 1, so that goes on top, so x minus 1. All right, then we have a negative power, so we know that it's going to be 16 minus quantity x minus 1 squared minus y squared is on the bottom. And then we have 1/2 power. So 1/2 power, so it's a square root. All right, so we got that. All right, so if you set this guy equal to 0, and you can see that we just have to worry about the numerator equal to 0, right? So it's going to be x equals 1, right? All right, let's look at the partial derivative of f with respect to y. All right, it's going to be very similar. So 1/2 say exactly the same quantity. So 6 minus quantity x minus 1 squared minus y squared. Raise it to the negative 1/2 power. All right, this part is going to be a little bit different. So it's going to partial of the inside with respect to y. So it's a negative 2y. All right, so we can cancel. There's a 2 on the bottom and there's a 2 on top, so we can cancel those out. And then we have, let's see, so we can rewrite this guy as, right? So it's still negative. All right, y is going to be on top, so I took care of the negative sign and the y. And everything else is the same as before, so I'm going to just go ahead and write the square root of 16 minus quantity x minus 1 squared minus y squared. All right, if you set that equal to 0, you can see that the y is going to be equal to 0. All right, so we have a critical point. So here, critical point would be at x equals 1 and y equals 0. All right, so we need to determine what kind of relative extrema or saddle point that this will give us. All right, so we need to do the second partial test. So we take the partial derivative with respect to x twice, second partial. All right, so we're going to take the derivative of that again. So we have, right, there's a negative sign there. All right, then here we have, all right, square the denominator, which means that you're just going to get the 16 minus x minus 1 squared minus y squared. Right, so that's not too bad. All right, then take the derivative of the top, which is going to be 1 times the denominator. So you're going to get the square root of 16 minus x minus 1 squared minus y squared, right, minus, right, so you have top is x minus 1, right, the derivative of the denominator with respect to x is actually the same as this whole thing. So it's going to be negative, so it's going to be positive here. And then you have x minus 1 over square root of, right, 16 minus x minus 1 squared minus y squared. Right? So what you get is going to be, let's see, this looks pretty bad, right? So I'm going to multiply top and bottom by square root of 16 minus x minus 1 squared minus y squared. And then you have a square root of 16 minus x minus 1 squared minus y squared. Right? So this way, we can simplify this to, alright, so the denominator is going to be, so you have a quantity 16 minus x minus 1 squared minus y squared. And then you have a first power and a 1/2 power, so it's going to be a 3/2 powered once it's they're combined. All right, then you're going to get, okay, so I'm going to distribute this square root guy to both of these terms, right? So from the first term, you just have to take away the square root. So 16 minus x minus 1 squared minus y squared, right? And then this one, you just have to cancel denominator here and cancel that. So you have a plus x minus 1 squared. So we can cancel this guy right here and that guy right there. So you're left with, right, so let's see, I have to, actually, I'm forgetting a negative sign here, so negative sign should be there. All right, so it's going to be negative, right, you have a 16 minus y squared, right, then you have the same denominator, 16 minus x minus 1 squared minus y squared, raise it to the 3/2 power. Right, so let's find the partial with respect to y. All right, so let's do that. So it's a negative sign here. All right, square the denominator. So we're going to go ahead and square that. So we're going to get 16 minus quantity x minus 1 squared minus y squared. All right. And then partial with respect to y is going to be 1. So 1 times the square root of 16 minus x minus 1 squared minus y squared minus y times and this whole thing. So because the derivative of the denominator is exactly that. So you have, so it's going to be negative, so it's going to be plus y over square root of 16 minus x minus 1 squared minus y squared. All right, so I'm going to use the same trick as before. Here, oops. All right, same trick as before. All right, multiply the numerator and denominator by square root of 16 minus x minus 1 squared minus y squared. Square root of 16 minus x minus 1 squared minus y squared. All right, so you're going to get, so this is going to be negative. All right, so the denominator is same as before. So you have 16 minus x minus 1 squared minus y squared. Raise it to the 3/2 power. Right? So in this case, you're going to get the 16 minus x minus 1 squared minus y squared. Then you're just going to get the plus y squared. So we can cancel negative y squared and the positive y squared. And you end up with negative right? 16 minus x minus 1 squared, and the denominator is exactly the same as before. All right, so we got that, right? All right, then we have to find the mixed partial too, so it's just a little tedious. Mixed partial here is going to be, all right, so we want to find a mixed partial. All right, so we take this guy and take the actually take the top guy here, take the partial with respect to y. All right, so you have a negative sign, and also x minus 1 is just going to be a constant, right? Then so you have a square root on the bottom, so it's a negative 1/2 power. So let's take the derivative. So put negative 1/2 in front. Right, keep the same quantity, so you have a 16 minus x minus 1 squared minus y squared. Right, so it's a negative 1/2 minus 1, so it's negative 3/2. And then multiply by partial derivative inside with respect to y, so it's going to be negative 2y. Right, so we got that, then we can just cancel. Let's see, we can cancel negative 1/2 and the negative 2. And that's about it, right? So this is going to be, right, so negative sign is in front still. So you have x minus 1 on top. And then you have, we also have y. And then on the bottom, you have 16 minus x minus 1 squared minus y squared, raise it to the 3/2 power. All right, so we got everything we need, right? So here, let's find a value here. So if you have f of, maybe I need a little bit more room here. So let's find the f second partial with respect to x evaluated at 1, 0, right? All right, so you plug in 0 for y, so you have a negative 16 on top over, all right, so you have, let's see, plug in 1 here and plug in 0 here, so you have a 16. So 16, then 1/2 power square root is 4, and cubed is 64. So you have a 64 actually. This is 16. 64, so give me times 4, right? So that's 64. So maybe I'll just go ahead and do it 64. All right, then this simplifies to. So 16 divided by 16, that's going to be 4. So we have negative 1/4. All right. Then you have f second partial with respect to y evaluated at 1, 0. All right. So if you look at the second partial looks like this. Right. So we plug in x equals 1, so you have negative 16 on top. And the 1 on 0 said again, this is 64, so it's actually negative 1/4 again. All right, then how about the mixed partial? X, y at 1, 0. All right, this one, the numerator is actually 0, so the whole thing is going to be 0. All right, so if you find the quantity d is going to be, so second partial with respect to x is a negative 1/4, times second partial with respect to y is negative 1/4, minus mixed partial is 0, squared is still 0, so this is going to be positive 1/16. So all we need to know is that that's positive. And then we know that second partial is actually negative, right? So D positive indicates that you have a bowl shape. And the second partial is negative, meaning that the bowl is facing down. So this tells you that that critical number is going to be a local maximum. So f of 1, 0 is a relative maximum, right? So let's type it in. Right, so we got the relative maximum, and actually we haven't computed it, so it's 1, 0, right? So here, 1, 0. So if you plug in 1 and 0, so it's a square root of 16, so value is 4. And at 1, 0, of course, is the local maximum. Right, that's the only one, so everything else does not exist, so I have to put D and E there, then you have a D and E, and here saddle point, there's no saddle point, D and E. We have D and E does not exist. Right, so let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.